The Sleeping Beauty problem is a thought experiment. The problem is stated as follows: Sleeping Beauty volunteers for an experiment. On Sunday, she is put to sleep. Once asleep, a fair coin is tossed. If the coin lands on heads, Sleeping Beauty is awakened on Monday and then put back to sleep until the experiment ends. If the coin lands on tails, she is awakened on Monday, put back to sleep, and then awakened again on Tuesday with no memory of the Monday awakening. After Tuesday, she is put back to sleep until the experiment ends. In each awakening, she is asked, "What is your belief that the coin landed heads?" Here is the probability of heads, taking note of the day of the week. P, H, equals P, H given M, P, M, plus P, H given T, P, T. This is the worst of the math that is needed to understand the problem. It reads, the probability that the coin landed heads equals the probability that the coin landed heads given that it is Monday times the probability of it being Monday plus the probability that the coin landed heads given that it is Tuesday times the probability of it being Tuesday. Now for the source of the discrepancy. If one assumes that the experiment ends on Monday if the coin falls heads, then P, M, equals 2/3, P, T, equals 1/3, P, H given M, equals 1/2, P, H given T, equals 0, and P, H, equals 1/2 by 2/3 equals 1/3. On the other hand, if one assumes that the experiment ends on Tuesday if the coin falls heads, then P, M, equals 1/2, P, T, equals 1/2, P, H given M, equals 1/2, P, H given T, equals 1/2, and P, H, equals 1/2. As you can see, the source of the discrepancy is the assumption concerning when the experiment ends. If you assume the experiment ends on Monday, P, M, equals 2/3. But if you assume the experiment ends Tuesday, then P, M, equals 1/2. That is the key. And there is no basis for picking the one over the other, it seems. So, this is a true paradox. Or is it? If the experiment ends on Tuesday and the coin had landed on heads, Sleeping Beauty would be awakened on Tuesday but not have been asked the question. Thus, the experiment could have concluded on Monday or Tuesday. However, the logical end would have been Monday. Sleeping Beauty would know that the question would only have been asked on Monday if the coin had come up on heads. Therefore, P, H, equals 1/3 would be the logical probability for Sleeping Beauty to assume. She might simulate that probability by looking at her watch or a clock on the wall. Absent those possibilities, Sleeping Beauty might take a strand of her hair and break it to choose whether to say heads or tails. If the breaking point were approximately 1/3 of the way from her left hand, for example, she might choose heads. Can you think of other ways for Sleeping Beauty to select an option?